let's look at the basic Ansible configuration for a Linux server and a client. So I'm going to configure a Linux server and a client so you can see how it works. We have right here a Linux server. Well, there are all kinds of servers, but we have a server machine, and we want to install Ansible. Alright, so first thing I'm going to do is we want to install the EPEL repository. So we do a yum install EPEL release. So this repository gives you extra packages that we like to have and want to have installed on the system. After installing the EPEL repository, we want to install the Python pip manager, package manager, so we can get extra packages. So do a yum install Python pip. And after we are done installing the Python pip package, we can go ahead and install the Ansible package. There we get that installed. You can use the -y switch during yum if you do not want to press Y to accept everything. Just basically use the same command. You just put in a -y in here somewhere, and that's the same general idea. Since we've already installed the Ansible package, we can skip that and move on to the next step. I want to install the Python PowerShell thing that will allow us to communicate with Windows machines as well. So you do a pip install py. We get this package installed, and it tells us we should probably upgrade pip while we're at it. So let's go ahead and do that as well. Pip install upgrade, and we get that all installed and we're ready to go. Alright, so Ansible uses the SSH keyless authentication to communicate with its clients. So we need to first set up a public-private key pair, which we can do with the SSH keygen command. You can use extra options and tell it what kind of key, or you can just default to what the default key is, and you'll be done. Alright, so now that we are at this point, you can go to your .sh directory, and you can see that there are two files. There is the ID_RSA key, which is your private key, then the ID_RSA.pub key, which is your public key. Your Ansible machine needs to be able to connect to your client machines. And so what you need to know is you need to know the IP address of your client machines or the host names. So let's go ahead and switch over to our client machine. So here we are. If I type in IPAPPR, I can get the IP address. We can see that down in ENS32 section, we have an IP address of 10.230.150.2. We're going to remember that number, so we can configure it so we can talk to that client machine. Now, when we are connecting up, we need to connect up and use the keyless authentication, and we can see that there is no .sh directory. We need to have the SSH directory in existence before we can copy keys over and make things work. Now there are two ways to do this. You can manually create the directory, .sh, like that. However, if you manually create the directory, it will have the wrong SSH, wrong SE Linux context. So if you do ls-alz.sh, you can see that it creates it with admin home t, and that's not what we want. We want it to be SSH, actually create the SSH home t. If it does not create SSH home t, then you have a problem. You created the right one, so we're good. If you don't do that, and it's gone, you could also do the same thing and create your key pair. So sh keygen, and you don't need to do this, but you could do this and have it generate keys, and at the same time it will automatically create this .sh directory, which should get the SSH home T type right there. See the dot directory right there. So if you want to be created correctly, the SSH keygen command will create it correctly. It will set the correct permissions, and it will set the correct SE Linux context type. So I just recommend using the SSH keygen command just to do it. The other option is you can, from the client machine, try SSHing into a different machine, and when it saves your key, it will get it correct. All right, so we'll go back to the server now. On the server machine, we want to copy the ID RSA pub file over to the client machine. It doesn't matter what you call it, as long as you get it over the pub machine or the client machine. So you SCP ID RSA pub, and you can use the complete absolute path you want. You can do a root.sh type thing if you want. Anyway, you get the source file, and the destination you want to do is the root at your client machine, which was 10.230.150.2, I believe, and you're going to put it in the .sh directory, and you want to call it something that identifies as the server, so maybe server.pub. So it'll try copying over. It'll ask you for if you want to continue connecting. Say yes. You type in the root password for the client machine, and then you switch over to the client machine and take a look. And we go into the .sh directory, and you can see that the server.pub file has been copied over. You want to now copy that file, or the contents of that file, into the authorized keys file. We don't have an authorized keys file yet, so we can directly copy it over, or we can use the cat command, which is the safer option. So you cat the server.pub, and you add 2 greater than signs to append it to the if you already have an authorized keys file, it'll just add it to the end. In reality, what it does is it just creates a second file, and you can see the authorized keys file is this content, which matches exactly what we have on the server.pub file. So we do diff server.pub and the authorized keys, and we'll see that there's nothing different between the two. Anyway, at this point, we are ready to have the server communicate with the client. So if the server were to try copying that exact same file over to the client again, it would not prompt for the password because it's on the authorized keys file. All right, now we want to configure Ansible. So if we write ANSI Ansible version, we can see our version information. We can see the Ansible is there, and we can see in etc directory we have our configuration files. So let's go over to the etc Ansible directory, Ansible, and you can see that there is a file called hosts. We want to add the IP address of this host, the client machine, to this host file. So I will do a nano on my hosts file, and you can see there's different groups right here, like web servers and things like that. I'm going to go ahead and create a group. Well, let's use stick something in here. We don't need an example. We're going to call this our workstations. We're going to create a workstations group. You don't need to create a group, but it does make it easier if you want to send stuff to all of the workstations. 230.150.2, and that's the IP address of the workstation. And we exit out of there, and now it's ready to go. And Ansible, and I'll do all minus m ping. So this should try pinging all of our client machines and making sure that they ping correctly. And we can see that the machine was successfully pinged. Alright, so now let's try something a little bit more exciting. Let's tell the client machine we're about ready to reboot it. So we can do an Ansible, do all. Let's do a bin all. You can type in a command inside of this here. Prepare for a reboot. Alright. So now we click over to our client machine and we can see that it has this message that appears, prepare for a reboot. So you can start saying, oh no, it looks like we're going to reboot. So you can save what you're doing. And then the server machine, we want to send a command. Instead of using a bin, we use sbin and reboot. And then switch over to our client and we can see it's a black screen. It's in the middle of rebooting, which is, well, kind of good. Means it works. Alright. In addition to the reboot, we could also do things like try the ping again. Except instead of using the all, we're going to use a workstation. So, because it's in the workstations group, minus m, and we'll do ping. And it looks like it was successful, so I guess the client was booted up, and it's booted right here. Let's log in as root. And we get our terminal up again. Alright. And now we wanted to send another message over, we could do that as well. We can also send messages to just the machines that are in this work group, or in this group. How are you today? Of course, that's a strange thing to send, but that's okay. We go over to our client, we can see the message showed up, and there we have it. It has arrived and working. So you can use Ansible to install lots of packages on different machines and other things, but this is the basic configuration just to get the client and the server talking.